clusters. Okay, so in this, before getting into this group-based classification as well as the clustering technique, we should have an outline of decision tree techniques too. Okay, so I will give you the outline of decision tree. So this decision tree and all already you might studied. Okay, just we can have an outline of decision tree. After that, we can go to rule-based classification techniques. Okay, see, so here in these are the topics related to module 5. Okay, so in module 4, SOP alone is pending. Okay, it is problem. That topic covers involves some problem too. So I will share the video, or if time permits, we can discuss in the class, or otherwise I will share the video. You can go through the video. That is the only one topic I left in module 4. In module 5, we are learning about decision tree-based classifier as well as the rule-based classifier. So we can, since you have already studied this decision tree techniques and all, I wish to give you an outline of decision tree techniques. After that, we can go for rule-based technique. Okay, so let me start presenting. Yeah. So look at the picture, you are all able to understand the concept of decision trees. Okay, so decision tree is a tree where each node represents a feature. Feature in the sense attributes. Each link or branch represents a decision or the rule, and each leaf represents an outcome. Okay, so in case of your decision tree, we are having the components like the feature, which is otherwise called as attribute, and the decision. Decision is based on the rule, and it's based on the decision, we will be getting some outcome. So feature, decision, and outcome. Feature is the attribute here, okay, and each and every branch is the decision rule, and each and every leaf is the outcome. Okay, so this is what denoted in this diagram. You can look at this example too for this. So you are getting an offer. So in that you can take a decision that whether you wish to accept the offer or you want to decline the offer. So based on some metrics like salary and various other incentive schemes, and also the facilities what they are providing for including for traveling, and various other amenities will help you to decide to accept the offer or to decline the offer, right? So this is what given in this example here. So this decision tree technique will help you to take a decision where you will be following some set of condition. So based on that criteria, the tree will be constructed. So finally, the end of the tree would be the leaf, which is the decision, okay, or outcome. Okay, so decision tree is a supervised machine learning technique. It is based on divide and conquer paradigm. So you are dividing the whole data into number of subsequent subsets of data. Okay, so that it involves a divide and conquer paradigm. Okay, and similarly, you are having the idea where decision trees partition the space into patches and fit the model to patch. Okay, it will basically partition the whole data into number of small patches. Okay, after that it will fit the model to the respective patch. Okay, then a decision tree is a tree structure where each internal node, especially the non-leaf nodes, denotes a test on an attribute. Okay, each branch represents an outcome of the test. That is what we have seen in the previous slide itself. Branch represents the outcome where the branches ends up with the leaves, right? So it is discussing, it deals the outcome of the test, and each leaf node holds a class label. Okay, so this is what we are able to see in this decision tree also. We are checking a condition. If B is less than B1, then obviously if the condition is true or false, then we will be taking the decision as checking A. Simply checking A with A3. Okay, if the condition is true, then it will go to the next left side, or it may be a right side. Depends on the condition. What the attributes get satisfied, then based on that, the travel may occur. The construction of the tree will occur as such. So it is a classifier expressed as a recursive partition of the instance space. Decision trees are used for classification tasks. That we know already. It is kind of a classifier for classifying the data set. Okay, so it is a decision. Once again, we have one more definition for decision tree too. Decision tree is a decision support tool that uses a tree-like graph or model of decisions and their possible consequences, which includes chance, event, outcomes, resource cost, and utility. Okay, so this is an outline of the decision tree. Then classification problem in 2D view. So we have the data set represented with different attributes, where here it is denoted as plus minus as such. Okay, they are labeled as B1, B2, similarly A1, A2, and A3. Then we are classifying the problem into a 2D view and considering the tree as given in that tree structure shown here. Okay, so here the tree is formed based on the decision what we have taken depends upon the satisfaction of the criteria. Okay, if B is less than B1, then obviously it will go to the left. Suppose if the condition is false, then again the traversal will be on the right. Okay, so likewise we can set up the condition and can establish the classification problem. Okay, then building decision tree. So algorithm for building decision tree is called as the ID3. This is important one. This is iterative dictomizer 3. Okay, so this employs a top-down approach where we have greedy search techniques to search in order to search the possible elements and possible branches with no backtracking. Okay, so this ID3 uses entropy and information gain to construct a decision tree. Here we are following two important metrics. One is entropy and also the information gain. Okay, so it is a building decision trees is a very simple process. The core algorithm which helps you to build the decision tree is iterative decomposer. Okay, 3. This particular algorithm will help you to construct the decision tree. Okay, and here you follow two important metrics. So one is entropy, another one is information gain. Okay, so based on these two metrics, the decision tree is being constructed. Basically, the tree starts as single node initially, and where n representing the training records in D. Okay, then if the records in D are all of the same class, if all the records in the records are of the same class, then the node n becomes a leaf. Okay, if all classes belongs to the if all the attributes belongs to the same class, then this particular n becomes a what's this? 1 minute. Then this particular n representing the leaf node, n becomes the leaf node. Okay, so likewise we have to likewise we have 1 minute. Sorry. Likewise, the tree is constructed with the different attributes. Okay. Then suppose if the records in D are all of the same class, means then n becomes a leaf. Otherwise, the algorithm calls attribute selection method. So with this method, the attributes were selected, and this method helps you to determine the splitting criterion. Okay, so the splitting criterion tells us which attribute to test at node n by determining the best way to separate or partition the tuples. So we have to, we cannot randomly split the data sets for left side and right side. No, so left subtree as well as the right subtree must be formed properly by following the by properly following the splitting criterion. Okay, so this is an outline of building decision trees. Okay, so we have seen two important parameters are involved here. One is entropy, another one is information gain. Right. So entropy, this is the formula for calculating the entropy. So entropy using the frequency table of one attribute can be calculated by E of D equal to summation of I equal to 1 to C minus rho I log base 2 of rho I. Okay, so you can denote it with the different values provided with the frequency. Okay, then entropy using the frequency table, two attributes. If there are two attributes, then what will happen? So there is one attribute only one attribute. It is named as E of D. If there are two attributes, the entropy calculation may differs as given in this formula. If the sample is completely homogeneous, the entropy is 0, and if the sample is equally divided in the sense it has the entropy value as 1. Okay, so entropy is the amount of uncertainty in data set. So what is the entropy? Entropy represents the amount of uncertainty in data set. That is what the entropy value. Okay, so this particular algorithm ID3 uses entropy to calculate the homogeneity of the sample. So it depends on the nature of the sample only. The algorithm have to split further so that that particular process initially that homogeneity of the sample should be verified. Okay, well, then this entropy for the single attribute we have seen. Similarly, entropy for using the frequency of two attributes also we have seen. So if the similarly, if it is homogeneous, what would be the entropy value? And if the sample is some sort of heterogeneous, what would be the value of the that particular value? Okay, particular sample that and all denoted here. That is, one is completely homogeneous, another one is what? It is not completely homogeneous, but it may be it may partially support to compute the proper entropy, and where depends upon the nature of the sample. If the sample is an equally divided, then it has entropy of 1. Otherwise, the entropy value will be 0. Okay. Similarly, we have information gain. So difference in entropy before and after splitting the data set on an attribute A is called as the information gain. Okay, so difference in entropy before and after splitting data set. So we are able to split the data set if you are able to identify the differences in computation of this entropy before and after splitting the data set, then the information gain can be effectively calculated by the formula gain of T comma B comma A equal to E of D, that is entropy of D, minus entropy of D comma A. Okay, so this is what the formula to calculate the information gain. Okay, it is the information gain is the decrease in entropy after a data set is split on a attribute. Okay, so we have to construct the decision tree based on these metrics. Okay, well, so this is all about the information gain. There are two different methodologies being implemented here. One is entropy, another one is what? The information gain. So you may get two more questions related with information gain. Okay, what is information gain and all, you can get it. Okay, then this is an outline of the decision tree algorithm. Then, before getting into the problem solving of decision trees and all, we discuss about the rule-based technique. Because for rule-based classifier too, this decision-based technique provides the basic idea, okay, how to classify and also that we must have a basic idea behind the decision tree, and then okay, the rule-based structure must be applied. Okay, so this is the way we are able to use the rule-based classifier. Okay, then where the decision tree took part of having some important attributes. Okay, then this is the rule-based classifier. In our physical class, I will teach you the problem which help problem solved using decision tree as well as the rule-based classifier techniques. Okay, wow. So here in this rule-based technique, so in our previous slide, we have studied about the decision tree techniques. Here we will be studying about the rule-based techniques. So this decision-based technique and rule-based techniques are mostly interrelated together. Okay, so this is the idea of introduction about rule-based classifier. Okay, so this classifies the record using collection of if-then rules. Obviously, rule-based means that we will be having some set of rules. Okay, 1 minute. So once again, I tell you that in our previous slide, we have studied about the tree-based classifiers. Okay, so adila we have seen the decision tree techniques, how the decision tree is getting created based on some set of conditions. Okay, so how the data can be split as a left subtree as well as the right subtree, and what are the metrics involved in this decision taking process, where which component should go to the left side and which component should go to the right side. Okay, so likewise, some basic information we have learned in our previous title, right? So here we have seen two important components in terms of what tree-based classification. Okay, in terms of tree-based classification, we have seen two important elements or metrics, you can say. So one is entropy, we have studied. Okay, one is entropy. Another one is information gain. Okay, one is entropy. Another one is information gain. Okay, one is entropy, another one is information gain. Okay, then we have seen that we came here for rule-based classifier because this tree-based classifier as well as the rule-based classifier are both are interrelated. Tree-based classifier and also the rule-based classifiers are interrelated to each other. Okay, then so let us look into the concept of rule-based classifier. Okay, so this the rule-based classifier basically classifies the record by using collection of if-then rules. So here we have only the collection of if-then rules. Okay, if the condition is true, then it becomes become getting color, or if the condition is false, obviously it may not get it. Okay, so the classifying records by using the collection of if-then rules is the concept over here. So rule if condition, suppose here we can specify the condition if A greater than B, then your decision should be Y, or its decision can be any other values. Okay, so here you can see that condition is a conjunction of attributes and Y is a class label. As obviously it is a class label. Okay, then LHS. So in terms of your Boolean representation, the LHS where the rule antecedent or precondition will be there in the LHS. Okay, similarly RHS must have must be a result of rule consequent. Okay, must be a result of rule consequent. So likewise, the rule-based classification techniques mainly involves two important steps to be followed. One is conjunction, another one is having less labels. Okay, so here you can see the example. If age equal to youth and student, if he is youth and as well as if he is a student, then we can say that by underscore computer equal to. Yes. Okay. So similarly, we can have we can set our own condition, and based on that condition, if the our own condition, based on that condition, that whole data set is being splitted into a components which is known and which is an unknown values. Okay. Then rule coverage and accuracy. A rule or covers an instance X if the attributes of the instance attributes of the instance satisfy the condition. Okay, then coverage of rule means the fraction of tuples that satisfies the condition of a rule. Accuracy of rule means a fraction of tuples that satisfy the condition that also satisfy the corresponding satisfy the consequent of a rule. Okay, the next one. Which is accuracy. So accuracy, we are obviously calculated in our previous methods and all. So similarly here also we have to calculate the accuracy where the fraction of multiples, fraction of tuples that satisfy the condition which also specify the consequent of a rule gets varied. Okay, then you can see that n covers equal to number of tuples covered by rule, or n covers of tuples. Similarly, d correct. So d correct, n correct means the number of tuples correctly classified by the rule, or number of classifiers, number of tuples that are correctly classified. Okay, then here you can see the formula for coverage as well as accuracy. You can see for coverage you can have n covers divided by d. Accuracy it have actually n correct divided by covers. Okay, so by calculating the covers value you can calculate the coverage value or the accuracy also. Okay, so in case of your rule coverage and accuracy, so the accuracy will be covered depends on the Depends on the rules actually. So here n correct and as well as the n covers, as it is denoted here, it denotes the number of tuples covered by the rule, or here n correct represents the number of tuples correctly classified by the rule, or. So this is the formula: n covers by determinant or modulus d. Similarly, n correct bar n covers will give you the result. Okay, so this is what the condition. So look at this example. If the status is equal to single, then class equal to no. That means wherever the status comes as single, it should be given as, or it should be entered as like that, such as coverage as well as the accuracy only. Okay, so depends on the conditions only it is getting framed. So this is an example for vertebrate classification. Okay, so we are classifying the vertebrates based on some certain rules. Here the rules are given here: give birth equal to no, and can fly equal to yes, means then you can say that it is birds. Can fly equal to birth equal to no, then live in water equal live in water equal to yes, means it will be if it is yes, means then you can say that it is fish. Similarly, we can have the rules for representing each and every data. Depends upon that communication, the outcome will be decided. Okay, so this is what the condition where training set, and we have training set, and it is given to the along with the algorithm. Okay, so now the rule based techniques. So now the rule-based techniques were being applied, and it is computed for the computer because it is about to compute the class label of unknown data. Okay, then finally we are able to claim the label where we are able to identify from the beginning. Okay, so this is what the idea behind the label or rule based criteria. Okay, then in this how rule based classifier works, how rule based classifier works, we are supposed to explain it. Okay, so just go through the words given here and have to apply the tuple. Okay, so where the condition is can be framed according to the according to the specification of the data. So here we have if give birth equal to no and can fly equal to yes, means then we can say that that particular class is bird. Okay, sorry, bird. Similarly, we can develop the condition for different applications, and we have to test our conditions. If any attributes or any data set meets this particular requirement, then obviously it is classified as the part of this rule-based classification techniques. Okay, so here the turtle triggers both R4 and R5, since the message predicted by the ruler are contradictory, and their conflicting classes must be resolved. Yes, obviously. Then dofish sark, this particular attribute will triggers the attributes. Okay, then we have to cover, or we have to ensure that the classifier can still make a reliable prediction, and even though a tuple is not covered by any of the rule. Okay, so this is the task we have. What lemur, turtle, and dofish shark. Okay, these are some of the basic techniques we are supposed to remember, and it depends upon the data set, the particular technique must be chosen. Okay, so this is what the case. Next one, the outline characteristics of rule-based set. Okay, so what are the rule-based sets we may have? Means mutually exclusive, exhaustive rules, and also non-exhaustive. Okay, so a tuple may or may not trigger any may trigger more than one rule too. So it may be rule 1, similarly it may be rule 2 also. So likewise, one particular element can be added or inserted at the respective solution as given in this. Okay, wow. Then here you can see that here you can see the different applications, like 1 minute. Okay, so similarly, we have exclusive rules, then exhaustive rules. Rules are not exhaustive means what we are supposed to do. Similarly, rules are not exclusive means what are the links we are able to submit. Then we have to identify a user's default class. Okay, then have to find the default rule. Okay, if the condition, if it satisfies, then it is goes to class where the default class occurred. So that means if both the values becomes 0, then the class would be default class. If the default rule has an empty attachment and is triggered when all the other rules have failed. Yes, obviously. Difficulties is known as the default across this platform, and it is assigned to the majority class of training records, which is not covered by the exchange tag rules. Okay, so these are the important points you should remember about these things. Okay, then the rest of the things, only few slides left here. Then I will share the PPT and material. You can go through it. So this is the decision trees to two rules. One is from decision trees to rules where you will be you applied the normal way of applied the normal way of analysis, and another one is the specifically for the linear as well as the regression models. Okay, so refund, if the condition is true, then you can go for true blue color. Then if the condition is false, then you have to go to marital status. If it is true, single child or two child, and here it may be conditions as only one. Okay, and this for this particular decision trees and rules, we are supposed to provide the correct syntax of the decision tree along with the along with these along with this rules, along with these rules. So here, from this decision tree to rules, you are able to see that we in this example itself, you can see that we have refund. Okay, so obviously we will be deciding whether you will get or whether you have to refund something or you want to keep it with you. So likewise, if it is a refund condition is true, then no need to do anything. Then if the condition is false here, then we have to set the marital status. And also if the marital status also what's that also if it is a true, if it's true as such, then it will give you the result as the taxable income level. Okay, similarly the marital status no, and also the value taxable income also not greater than 80,000 in the sense, then that also that value which fixed here will also affect the performance of this particular decision trees. Okay, then rules are mutually exclusive and exhaustive rules rule set which contains as much as information the tree required. Okay, so this is the decision tree and decision trees and also the respective rules. How the rule-based technique is been applied also been explained here. Okay, in the next class we will try to learn the next topic. Okay, about this except this model except this module 5's topic like decision trees and also the regression trees. Okay, so decision tree outline we have seen, but regression trees we will be seeing in the next class. Similarly, the rest of the other parameters also will be examined here. Okay, so 1 minute. So that's the way the decision tree is constructed here. Okay, you please go through the content and come with some set of preparation related to this. Okay. So by this, the outline of the rule-based technique also given, but we need to collect various other sources too and to explore this particular techniques. Okay, wow. So this is the case. One minute, I will take this syllabus and let you know the content. After that, okay, or otherwise I can take attendance. After that, we can discuss.